Hello everyone, my name is Chidowere Jombu, your usual presenter. In today's lecture, we are going to continue with our lecture on the basics of electrical circuits theory. And if we can recall back, in our previous class or lecture, we stopped at parameters and we succeeded in defining what a parameter is, that there are various electrical elements which we normally see in an electrical circuit. And we say they are classified into two. Into two means parameters may be lumped or distributed. Therefore, we categorize them into four now, having lumped elements, lumped circuits, distributed elements, distributed circuits. We take them one after the other. So, what is a lump element? A lump element are those elements that are concentrated in a particular point or a place in an electrical circuit. They have fixed values, either in ohms, in farads, or in henries, depending on what is given. For example, now let's have a circuit like this. Now, this is our voltage source. Then we have our resistor R here. We have our inductor L here. We have our capacitor here. Capacitors with C. So you can see that they are located in a single space. Look at the resistor located in a single space in this circuit. Look at inductor located in a single space here. Look at the capacitor located in a single space here. What it means is that these various elements of this lumped circuit can be detached. They can be detached and we'll have something like this now. This is R. We can still have this way. This is inductor L. Then it can still be detached this way. This is our capacitor C. You can see we have detached the whole components, meaning that they can be separated, and that is why they are located in a very single point and concentrated in a particular point in this very particular circuit. So this is on lumped element, and we have cited examples as resistor, inductor, and capacitor. These are known as lumped elements. And of course, the lumped circuit now is almost what we have just drawn here now. This is example of a lumped circuit. And what is a lumped circuit? A lumped circuit is a circuit that contains the lumped elements. They contain the lumped elements. Then another thing you should know about lumped element is that the applied voltage and the current, they are bigger than the physical structure and size of the various lumped elements. They are negligibly small when you want to now compare them in terms of the applied voltage and the current. Okay, we quickly go to distributed elements. What are distributed elements? Distributed elements are elements that we normally have in transmission lines. For example, we have the resistance of the transmission line, the capacitance of the transmission line, the inductance of the transmission line. All these things are various elements of a distributed element. Then we have the distributed circuits. Distributed circuits are circuit that contains the distributed elements of the transmission lines. Then another thing that is worthy to note is that the wavelength of the distributed elements are comparable to the applied voltage and current. They are comparable, quite unlike the distributed, quite unlike the lumped elements, because the lumped elements are negatively small. So you can see the differences there. So, okay, now example of a distributed circuit is the transmission line. If this is the transmission line now, let's take that this is the transmission line. With this transmission line now, these are our conductors. These are our various conductors, where our various current flows. You can see that the capacitance are distributed entirely on this line. The inductance are distributed along this line entirely. The resistance are distributed entirely on this line. They are not fixed. They are not separated. You cannot detach them. You can't. Just like you can detach the lumped elements. So you can see these are the major differences between lumped elements and distributed elements. Now, another thing we are going to look at is the major differences now between lumped element and distributed element. Now, one, in terms of size, the size of lump elements are very, very small. They are negligible compared to the size of the distributed elements. And another thing is that while the lumped element can be detached, they can be separated from the circuit, just like we did here. You can see arrow is separated here, which is the resistor. The inductor is separated here. The capacitor is separated here. But you cannot achieve and realize that when you are dealing with distributed elements. So distributed elements are fixed. They are fixed. They are distributed entirely along the transmission network or on the transmission line. Then another thing now we should look at is that in terms of the lumped elements, their wavelength again is very, very small comparable to the what distributed elements. Wavelength of these are equal. They are equal. They are commensurate to what is given out and what is coming in. But in a lumped element, the lumped element, that means their own wavelength is very, very negligible and very, very small. So this is where we draw the curtain closed on parameters, classification, and on lumped elements and distributed elements. Don't forget, you follow me on my page at Tidowere Jumbo. I meet you again in my next edition.